Have you ever tried to sort things into groups? We humans are pretty good at it, aren't we? We sort our clothes by color, our books by genre, and even our friends based on shared interests. This knack for categorization is not just useful in organizing our closets or social circles, but it's also a fundamental concept in the world of mathematics. Mathematicians, you see, are rather like the ultimate organizers. They deal with groups, but not the kind you might be thinking of. In mathematics, a group is a set of elements that interact in certain fascinating ways. Think of it as a party of numbers, where every attendee has a unique role, and the overall harmony depends on these roles interacting just right. Now, within this grand party, there are some groups that are particularly intriguing. Just like we group fruits based on color or shape, mathematicians group numbers based on their properties, and one such fascinating group is the finite simple group. So, what exactly are these finite simple groups? Think of a finite simple group as a puzzle. A puzzle that's finite, meaning it has a limited number of pieces, and is simple, meaning it can't be broken down into smaller puzzles. These are the essential features that define finite simple groups in the mathematical realm. Let's travel back in time and delve into the history of finite simple groups. The year is 1861, and a brilliant mathematician by the name of Camille Jordan introduces the concept of finite simple groups. His work forms the basis for the study of these groups, setting the stage for future mathematicians to unravel their complexities. Fast forward to the early 20th century, we see the emergence of the classification of finite simple groups. This is a monumental task undertaken by several mathematicians over the course of many years. Their goal? To create a complete list of these groups, a catalogue, if you will, of all possible finite simple groups. Now let's break down the concept further. Imagine you have a set of objects. These objects follow certain rules when combined, and these rules form the structure of the group. The simple in finite simple groups means that this structure cannot be broken down into smaller parts. It's like the smallest piece of a puzzle that can't be divided further. The finite aspect implies that there's a limit to the number of elements in the group. Just like a puzzle with a set number of pieces, a finite simple group has a specific number of elements. It can't go on indefinitely. So why is this important? Understanding finite simple groups is like understanding the basic building blocks of a complex structure. They're like the atoms of the mathematical world. By studying these groups, mathematicians can gain insights into the larger structure of mathematical theories. These groups are the building blocks, the atoms, if you will, of all finite group theory. Now, why would we want to classify these finite simple groups, you may ask? Well, imagine you have a jigsaw puzzle. It's a lot easier to complete if you sort the pieces by color or edge, right? Classification works the same way. By categorizing these groups, we're able to understand their structure and properties more clearly. The classification of finite simple groups is akin to a grand puzzle in the realm of mathematics. It is one of the most significant achievements in this field, a triumph comparable to scaling the highest peak or traversing the deepest ocean trench. It provides a structural blueprint, a map, if you will, that allows us to navigate the complex landscape of these groups. This classification process is not just an academic exercise. It is a critical tool in our mathematical toolkit, helping us to unlock the secrets of these groups and shed light on their fascinating characteristics. Classifying these groups was like mapping the stars in the universe. It gave us a better understanding of the mathematical world around us. So what's the big deal about these finite simple groups? What are they used for? Well, the applications are as fascinating as the theory itself. In coding theory, finite simple groups play a crucial role in error detection and correction, ensuring the integrity of data during transmission. In cryptography, they provide robust security frameworks, safeguarding our digital communications. And in the realm of physics, they're used to model the symmetries of the universe, helping us better understand the world around us. But it doesn't stop there. The study of finite simple groups is a fertile field for ongoing research. With every new group discovered, we unravel another layer of mathematical mystery, expanding our understanding and opening up new possibilities for application and innovation. The future of finite simple groups is bright and full of potential. The study of finite simple groups is a journey, and like all journeys, it's full of surprises and discoveries waiting to be made.